Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's say today's LeetCode problem 1022, sum of root to leaf binary numbers. It's easy mark. Let's read the question. You are given the root of a binary tree where each node has value 0 or 1. Each root to leaf path represents a binary number starting from the most significant bit. For example, if the path is 0 1 1 0 1, then this could represent 0 1 1 0 in binary, which is 13 in decimal. Okay, for all leaves in a tree, consider the numbers represented by the path from the root to that leaf. Return the sum of these numbers. So the test cases are generated so that the answer is a 32-bit integer. Okay, let's see the constraints. The number of nodes in a tree can be 1 to between 1000 and nodes value can be 0 or 1. Got it? Now let's see this example. So what they're saying, so we need to find all the paths from root to leaf and we need to find their sum. So what are the possible paths? So it can be this, or it can be this, or it can be this, or it can be this. So we need to find all sums of these leaf nodes. Okay, so how we can do that? So we are going to start from the root node. So we need to follow the pre-order traversal, right? Why you need to follow the pre-order traversal? Since we need to consider the root node first. So in pre-order traversal, we'll consider the root node first, and then we'll consider left, and then we'll go to right. So in this scenario also we'll do the same. So first we'll start from the root node. So initially it would be we'll have a string and we'll append that to root node. So initially we'll have 1 here, and then we'll come to left. Here we have seen 0, so we'll append 0 to that string. So current string is 1 0. Now we'll go further to left. So here we have 0 again, so we'll append 0 to the current string. Now string became 1 0 0. So now we'll check, is this a leaf node? What is a leaf node? Leaf node matlab we don't have any left and right, so it is null node. So we don't have any left and right, so this is a leaf node. When we are at leaf node, we'll just append this to the sum. We'll convert this into the integer and we'll append that to the sum. So current sum is, so we'll append this 100 matlab 4, we'll append to the sum. Now we'll come backward. Current string is 100 and we'll go right. So we have seen 1, so we'll append 1 to the string. Now this is also a leaf node since we don't have any left and right, so we'll append this to the sum again. So now sum becomes 100 is 101 is 5. Now we'll go backward and we don't have anything, so we'll go backward again to the, now we'll go to the right. So in the right node we have seen 1, so we'll append this 1 to the string. Initially we have 1 and we'll append 1 to the string, and then I will go left side. So I have seen 0, I will append 0 to the string. Now my string became 110 and this is a leaf node. So what I will do, I will append this to the sum. So 110 means 6. Now at the next time I will go to the right side. Now my string become 111. So, and this is a leaf node, so I will add this to the sum. Now my binary tree is completed. I will go back to the root node and I will return the sum. So what is the sum here? 4 plus 5 plus 6 plus 7 is 22, and which is the answer for this input test case. Got it? So now what I am doing here, I am generating the binary string every time. So instead of doing that, we can directly calculate the value of the path while traversing. So how we can do that? So initially when we are at the root node, what we'll do, we'll just check, how do we calculate the binary values? It is like, so if it is our binary value, how we'll do that? It is 2 to the power of 0 plus 1. Sorry, it is 2 to the power of 0 into 1 plus 2 to the power of 1 into 0 plus 2 to the power of 2 into 1. So it would be 2 to the power of 0 is 1 into 1 plus 2 to the power of 1 is 2 into 0 plus 2 to the power of 2 is 4 into 1. So it is 1 plus 0 plus 4, which is 5. So this is how we calculate the value into the decimal. So how we can do the same thing while traversing? So what we'll do is we will just we will keep track of a number, consider it as a current number. So while traversing we'll do current into 2 plus root dot value. So while we are doing that, we will be able to get our answer. So initially we'll start we'll be at 1 and our current will be 0. So what we'll do, 0 into 2, which is 0, plus root dot value is 1. So in this case our value is 1, and we'll go further. So we'll do the same thing. So current dot value, current is 1 into 2 plus root dot value is 0. So 1 into 2 is 2 plus root dot value is 0, so it should be 2 here. So here the answer will be 2, and we'll go further. Now we'll repeat the same thing. 2 into 2 plus root dot value is 0, so which is 2 into 2 is 4 plus 0, which is 4. So and when we come to the leaf node, our value become 4, and we'll just add this 4 to the sum. And and the second thing is we'll come back and we have value as 2, and we'll go further here. We'll check again. 2 into 2 plus current value is 1, so it will become 5. So we'll add this 5 to the sum. Got it? So like this we can calculate the sum while traversing the tree itself, instead of creating a binary strings every time. Got it? Okay, now let's see the time complexity for this program. So time complexity for this program is, so we are only traversing each node one time, so it would be big of n. And what is the space complexity? We are not using any space complexity. It is only recursive stack. So recursive stacks would be height of its tree. Got it? Height of tree. Okay, now let's try to write code for this. Okay, I will take a global variable called into sum, and then we'll initialize sum to 0. Sum is equals to 0, and then I will do the DFS traversal. It would be pre-added traversal. So what I will pass is, I will pass the root node, and initially the sum will be 0, and I will return the sum here. Now let's write method for that. The def method public, I will not write anything from this method, and I will be DFS tree node root, and initially will have int value. So first thing is the base case. You need to check if root is double equals to null. We'll simply return, otherwise we'll add that to the value. So how? Value is equals to value into 2 plus root dot value. Okay, so once we add this value, we'll check if it is the root node or not. If root dot left is double equals to null, and then root dot right is also double equals to null. That means if it is root node, we'll just add that to the sum. What it? Sum plus equals to value, and if it is root node, just will return from this. Got it? So directly we can also return, otherwise we can do traversal also. So directly return from here, and we need to do traversal for root dot left and root dot right also. We'll do root dot left, and we'll pass the value, and we'll do it same for the root dot right, and we'll pass the value. Got it? That's it. Now let's try to submit this code. Yeah, it is accepted. Now let's submit this. It is accepted with 0 milliseconds runtime. If you like my content, please do like, share and subscribe guys. Thank you.